16.5, finding values from integrally defined functions. This is what I like. This is back to just finding area on a graph. We've got a g function, which was the original, is defined by the antiderivative of f. Find the value of g of 5. So all I'm going to do is plug in 5 for x, which means my integral then is saying from -5 to 5, f of t dt. So we're going from -5, I've got to make some shapes here. There's a triangle. To 5 will be another triangle. Remember that below the x-axis is negative, above the x-axis is positive. Triangles are half base times height, so this looks like a 5 by 4, which would be 20. Half of 20 would be 10, would be negative. This would be 5 by 2, which is 10. Half of 10 is 5. So we just have -10 plus 5, which nets -5. Easy enough. All right, number 2. We've got from 6 to our x value, and they want to find g prime of -3. So we are thinking g prime of x and then taking the derivative of 6 to x f of t dt. These cancel. So really g prime of x is equaling f of x. And they want to find g prime of -3. So I don't have to do anything except for look at the f graph and find out the y value when x is -3. So no area on this one. When x is -3, it looks like y is 0. And that's it. Okay, and then we go up now to where it has a second derivative of -2. And notice now this is f of x, so g is the graph given because this is the antiderivative. F was the normal function. Okay, and we're going, so I think f prime of x, take the derivative of the antiderivative, which makes them cancel, and says that f prime of x would equal g of x. And so f double prime of x, is thinking I'm priming again, would be g prime of x. And they want f double prime of -2. So I'm really finding g prime of -2. Well, g prime just means the slope. So this is just a slope at x equals -2. That is right here. So I see that this is going down 1, right 1, down 1, right 1, down 1, right 1. So the slope is -1. So that's it. So you can kind of see the order here as if they just want g of a number. You're just plugging that into your integral. So you are finding area. That gives you a y value. The first derivative is really just the function value on the graph. Second derivative is actually the derivative of this derivative, which is the slope of that graph.